All right, I know we're at time. I should probably get going. Come on in, take a seat. And we'll let folks get situated for a minute, scan that code. I'll explain the stuff going on the page. I think from all the answers here, I have my answer that nobody has actually looked at this ahead of time and probably hasn't done any of the pre-work. Is that true, or has anybody done the pre-work? I think you said you did a little bit. Yeah, but if you haven't, it's okay, because I've set this up specifically so we can go without it, and then we can finish up. If we have time, right, we can do some of that after. It's not a big deal. All right. I think we're at 9:02. Let's go ahead and get going. Good morning, and thank you all for coming on this very first workshop of the day. I'm David Jones-Gilardi. I'm a developer relations engineer at DataStax. I'm a coder and a Gen AI nerd. I've been coding for about, almost 30 years now, which is weird when you think about what we're doing today and how things have changed, right, compared to what we were doing back in the, say, 80s and 90s, where you had a terminal and maybe man pages and a Riley book or something like that. So it's way different. And then Melissa will eventually show up. There's Melissa. Hello. Melissa is a fellow Gen AI content junkie. She's also a developer relation engineer on the team. So if you have, while we're going through stuff, feel free to ask questions. I want this to be interactive, right? If something's not clear, say something, right? If you're trying to do something, if you're having any trouble or whatever, say something. Melissa's here to help, and same with me. All right, so the overall agenda. So what I'm going to do is, well, first I want to ask some questions, actually. How many of you have already worked with Gen AI flows? And have we coded with them? Or like you're in ChatGPT? I see one, okay? Like ChatGPT kind of stuff, right? How about agentic flows? How many of you are familiar with agents? We got a couple, all right. So what I'm going to do here is I'm going to start off with just a quick recap, a quick primer on what agents are, what tools are, and then I want to level set with expectations, what we can actually expect from agents, because it might be a little different than what you might think. Then we're actually going to get in, we're going to start hacking on stuff, right? So I'm not going to take a lot of time on the primer thing, but then we're going to actually get into Langflow. So Langflow is a visual IDE. It is used to build out Gen AI and agentic workflows and stuff. And you'll see on the page, I'll show you on that QR code that you scanned, there's a spot for the installation. You can do a desktop install, you can do a pip install, up to you, or you can just watch, right? And then we're going to actually build a simple agent. We're going to build out a simple agent, we're going to build on that, and then we're going to move into doing some agentic RAG. Now, how many of you, go ahead.
Quick question, is Langflow supposed to be zero code to follow the negative?
Yeah, so the answer is it is a drag and drop visual IDE that you can, without code at all, you can absolutely build out Gen AI and agentic workflows that way. But for those coders here who want a deeper level, that's there, and I'm going to show that to you. I'll show you both, right? So yeah, you can do that. Now, is anybody here familiar with RAG? Have you heard that acronym? So a bunch of you already, right? So what we're going to do is we're going to take RAG and we're going to make it agentic RAG, right? So this is a case where we can expose a RAG pipeline as a tool to an agent to do some really cool things. And at the end, I'm going to give you a whole set of resources. As a matter of fact, that Notion page that you go to at the very bottom are a set of like articles and things that are from people out in the agentic world. Some of them are really quite great resources if you're getting into agents. Okay, so let's just go ahead and take, like I said, a quick primer on what agents are. I'm just going to pop these up on the page. How many of you saw the CES NVIDIA keynote so many months back with Jensen Huang, right? I think he just so succinctly explained what agents are. That's the quote at the bottom. AIs that can perceive, reason, plan, and act. I think that was a really great explanation. The one above it is actually one that comes from a Google paper. It says a generative AI agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal. So the key things here about agents is they have agency, they have reasoning ability, things like that. Regular LLMs, right, even though now some of them have some reasoning, they don't have an ability to interact with the outside world or anything like that. By the way, for those of you who just joined, scan the code. That'll bring you to the workshop page, and that's where materials and things will be. Don't worry about the pre-work. I know a couple of you have heard me say that like 5 times now. Yeah, I'll let you guys scan that real quick. Come on in, take a seat. Hello. And scan that code real quick. That'll bring you to the Let me know, and I'll come back to that. Let me know when you're ready. Okay, so, all right, so great. So agents are different from just pure LLMs, right, in the fact that they have this agency. Now, agents wouldn't be able to do much without their tools. They need tools to enact this agency, and tools bridge the gap between the agent's internal capabilities and the external world. So you're going to find, by the way, has anybody heard or gotten on the MCP bandwagon yet? Right? Great. I see some folks, right? So MCP is not the only thing. MCP is like the USB-C for tools and agents. It's just greatly expanded what you can do. I'm going to show a little bit of that. But really, tools are the key. Tools are the key. That's the way that the agents can then take action in the external world. All right, so this is my AI-generated slop of my depiction of what an LLM feels like before it's an agent, right? It's got all these cool capabilities, but it's a little hemmed in, right? And this guy's particularly happy. He can't wait to explore the outside world, and he happens to have jazz hands for tools. That's how he's going to connect. This is just me being funny. I'm not kidding. I was actually working on something, and I ended up generating this, and I laughed for like 5 minutes, and I said, I'm going to put this in all my stuff now. Anyway, so if I pull from the Google paper, right? So there's a Google paper that is actually in the resources that I'm giving all you, and I really like their illustration of what the agent runtime looks like. So at the bottom there, you see the model, right? This is for the last two and a half years, like when ChatGPT first came out, I mean, the AI stuff was already happening, but when the initial LLMs came out, right, they didn't have any of this other ability, right? It was just the data that they were trained on and such like that. So the runtime builds on that model, right? So you still have the model in there, but then it adds this orchestration layer, right? So now it has the ability to reason. It has short and long-term memory. You might see this if you go to Anthropic or ChatGPT or any one of the apps now, they've baked this in. Right, as you're talking, and you see the memory updated and things like that. They even fine-tuning, all sorts of things that are baked right into it. What you're seeing is no longer just the pure LLM. You're seeing an agentic experience, right? You're doing that right now. And then the tools. I mentioned the tools are super important, right? So there are now, honestly, there got to be thousands of them out there. There's almost too many, right? But the one I really want to point out there is that I mentioned MCP. So MCP has really exploded. I think Anthropic made a good call with trying to make like this universal interface. And with that, it has greatly expanded out what you can do. Now, Langflow itself, we're going to get into that in a moment, already has the ability to interact with, and it has all sorts of tools, and then MCP just expands that list, right? And to the question earlier, you can drag and drop these together and build out a full agentic flow. All right, so I mentioned that level set thing. So this is important to really level set what agents can and cannot do. For one, not all models support function calling, right? So if you try to use a model as an agentic model that does not support function calling, you're just going to get a lot of errors, right? It's going to be like, I don't know what you're talking about. I don't have support for that, things like that. Berkeley actually has their Berkeley function tool calling page. That is, I actually have that at the end of this. And they do a pretty darn good job of keeping up to date, but not just showing you the models that support tool calling, but rating them based off of all sorts of criteria and everything. But this is key here, right? Again, not all models can execute on function calling. In Langflow, though, when we use the agent component, which I'll be showing you, the models that are in there, those are all filtered for function calling models, right? So it makes it a little easier. When you are using tools, the tool name and description are super important. Right? Now, if you're doing something at MCP, well, that's actually part of the spec. When you call the MCP server for a particular tool, it's giving you that information. But when you're building your own or interfacing with your own, which, like what we're going to do in the agentic RAG stuff, it is super important that the name and description are super descriptive. Why? That is what the agent is going to use to determine what tool to use. What does it do? What are the input and output parameters? Like all sorts of things. So you've got to be very descriptive with the tool name and the description. Now, execution time might be longer than you're used to. How many of us come from a world before LLMs? And I know I was building apps that usually you're dealing with like thousands of operations a second or something like that. But then you put an LLM in the mix, and now all of a sudden operations that I would normally expect might take milliseconds are taking many seconds, right? And it's not, the LLM's doing a lot of work, right? Well, agents actually kind of make that a little bit more depending on the use case. Right? Because the agents, they have agency. They can iterate, right? They might be using tools like, say, Tavly or Google Search or something that's going out to the web, pulling back results, culling all that stuff. It takes a moment, right? So just setting the expectation that depending on what you're asking your agent to do, it might take 30 seconds. It could take a minute, right? Depending on what it is. Also depending on model speed, all sorts of parameters that get into that. And then finally, you don't always need to build an agent. If you can do it without an LLM, if you can do it with just an LLM, do that, right? Why? Agents tend to take up more tokens. They tend to eat up more of that. Now, if you followed, how many of you saw the recent announcement from OpenAI with 4.1, right? They just talked about that, right? And one of the big things that they pointed out was like, with 4.1, these models are actually cheaper. The token cost is lower, even though they're better models and that kind of deal. Wonderful, right? The providers will hopefully keep going on that track. But when you are using agents and that kind of deal, especially ones that are reaching out into the world and getting, like, scraping web pages and that kind of deal, you're eating up a lot of tokens in those iterations, right? So you don't always need to do that, is what it comes down to. Okay, so I said we were going to hack stuff. Let's do things. So we're going to use Langflow. Probably not surprised, because it's all over like everything we're doing here. Now, I saw a bunch of people come in, so what I'm going to do is I'm going to pop back over to that QR code for you. Let's go all the way back. It's my reversing. There we go. Scan that QR code for those of you who want to hack on stuff with us. And once you do that, you're going to get to a page that looks like this. Right? You're going to see this hacking agents workshop page. Like I said, don't worry about the pre-work. So what we're going to do is we're going to come down to this Langflow section, this install Langflow. And there are two ways to do it. You can either just watch me, or if you want to do it with me, you can do a local Python installation. For those of you familiar with Python, uv pip install Langflow. That's there in the link. Or there is a new Langflow desktop. We just released this like within the last so many months. It's an alpha, but it's super fast. It's actually quite easy to install and that kind of deal. So either one, I'll give you guys a moment to do that if you have not already done this, as I drink my coffee. Oh, yeah, of course. There you go. And if you would, as you're getting them, for those of you who are going to launch Langflow and stuff as you're doing it, just give me like a thumbs up or something like that. Oh, I said if you're gonna actually do like install Langflow, if you're gonna run it locally and you're gonna do it with me, just let me know. So that way I get a feel for folks that are doing that. You're good? Wonderful. Did you already have it installed? You did. Have you already been working with it? Oh, great. Okay. I'm curious. I'm just gonna totally call you out here. Like, what are you working on?
So we did a lot of database connections with it.
Okay.
And building this for agents.
Got you. Very cool. What version are you on? Do you know?
I was actually using it last, like, 2 months ago.
Okay.
Yeah,
Okay.
I'm not sure what got it since then.
Okay.
We switched to Vercel VK.
Oh, I got you. Yeah, and yeah, Vercel, like, you can totally mix and match that stuff. Yeah, absolutely. All right, everybody has the QR code who needs it? Awesome. All right, let me go. Go forward again. All right. Great. So while you're doing that, just a couple things. What is Langflow? I mentioned earlier it's a visual IDE for building out GenAI and agentic workflows. It is built on LangChain, right? So if you're familiar with LangChain and that structure, some of this is going to feel very familiar to you. But it's not constrained LangChain, right? Langflow has its own code and things like that as well. And it's real, I would say one of the best things that it does. It's been built to be model and vector store agnostic. The point of it is to allow, to enable folks to be able to build AI workflows extremely fast without code, using pretty much any model or vector store and such like that, right? So it itself is not a language model or an AI agent. It is a framework for building them, right? But you'll see that. And again, as I just said, it's not limited to a single vendor or anything. So here's what I want you to do. Once you've installed Langflow, there's really kind of two ways you could do this. We're going to skip over this flow1 job listings file ingest. That's part of the pre-work. Don't worry about that one. What I want you to do is we're going to come all the way down to this agentic fund, this flow2, this one that's a simple agent. Now in the Notion, if you hover over the file and you see the little ellipsis here, if you click on that, you can just say download and just pull that file down, right? And then when you do that, when you're in Langflow itself, I'll just show this to you, right? Let's say I pull this down. You're probably going to see it. I probably have like 1 million copies of it, so. But if I'm here in Langflow, like if I've launched Langflow, and I'm here, there we go. I can just grab the file and drag and drop it right on there. I can just drag and drop it right on there, and it'll load it up. Or fail like I just did, because I did that wrong. There we go. Try that again. There we go. Oh, I don't know why. I just clicked something weird. All right, well. There we go. There. Okay. Yeah, you can just drag and drop it in there, and then it'll just show up. And so it'll come up like a little thing like this. Now, if you don't do that, you could go to New Flow, and you'll see that there's all of these templates in here. There's a ton of them. There's a bunch of agentic ones as well. And we're essentially just doing the simple agent, right? You could just click on that. But again, the Notion page has all the flows in there. So I'm going to open this up. Now let's look at the landscape a little bit, right? So on the left-hand side, you're going to see all of these components. And like I said, Langflow itself is built to be this visual ID drag and drop kind of interface, right? So in order to communicate with an agent, you're going to need some inputs. You're going to need outputs. You're going to need the agent itself. You're going to need a model, right? You need these things to work with. And so you'll see on the left-hand side here, I've got all these different types of options. I have all sorts of data things that I can do. I can make this a webhook, all sorts of processing functions and that kind of deal. But what I really want to point out here are these models. I know I've mentioned it a couple times, but totally, like there's support for all sorts of model providers in here. And then within them, all sorts of models, right? A single provider has a bunch of models, right? For those of you who are interested, by the way, I get this question all the time. Can you execute against local models? Yeah, using Ollama, right? Ollama is one way that you can do that. So if you have local models via Ollama, you can absolutely hook those up here. And then the other part is on the vector stores, right? So again, from a vector store standpoint, yes, we're going to use AstroDB today, but there is support for all sorts of vector stores, right? So especially when you're working with, like, say, RAG pipelines or things like that, and you want to hook up to them, there's a bunch here. And then for my coders, if there's anything that's not here, right, there are custom components, right? You can make a custom component. You can get at the Python in every single one of these. So answering a question from earlier, like for the coders out there, they're like, hey, is it just this IDE? Is it just drag and drop, or can I do more? Yes, you can, right? So, and one thing that's fun, anybody here vibe coding? That's okay. That's okay if you have. You don't have to be ashamed. I do it all the time, actually. Especially for those of us who came before that was like a thing. I think everybody in the room probably, but like, it's so weird. But anyway, that's a whole different talk. But one thing that's actually super fun, I do this all the time. When I want to create a custom component, if I have an idea in mind what I want to do, this is a good template. You can literally take this as a template, feed it into ChatGPT or Anthropic. Any of them are very good at this. Say, conform to this spec. I want to do this. It almost always one-shots it. And I can just take that code, pop it in here. And now I have a custom component that does a thing. So anyway, so there is a lot of flexibility from that standpoint. Okay, so great. So now, we've got components and stuff over to the side. I'm just going to move that out of the way. But here's what I want to show you guys. So notice here, I have this agent component, right? This is one of the ones that you can actually drag over from the side view. So there's an agent component. So specifically, when I'm looking to make an agentic flow different from like a pure LLM, I want that agent component. So if you remember that runtime I was showing earlier, right, with the long-term, the short-term memory, all the reasoning, all that stuff, that is encapsulated in this agent component. And in that, you have all sorts of model providers. I'm going to go with OpenAI today, but you don't have to, right? You put in your key, pick a model, right? I'm going to stick with GPT-4o Mini. And then as I mentioned earlier, one of the key aspects of agents, in order for them to have agency and do things, they need what? They need tools, right? So you'll see in this case, in the simple agent, I have a URL tool and I have a calculator tool. Now something kind of interesting, I'll come back over to the components. Langflow has set it up, I want data. So you can pretty much take anything, and there's this tool mode. Right? So I can take a regular component that I might use in a more serialized way, but if I want to use it as a tool, I can use it as a tool, hook it right up to my agent. Right? And now, funny enough, like if I was doing like an API request, but I wanted to be lazy, right? Let's pretend I want to be lazy and I don't actually want to figure out the API. I can just point it at the URL, say, here's what this looks like, go figure it out. Right? Depending on the model, it might get it right. Like sometimes they actually do a really good job. I don't mean to, by the way, suggest that if you use tools, you're lazy. That's not what I'm getting at there. Anyway. All right, so in this case, what do I have? So I have an input, chat input. I have my chat output so I can communicate with the agent. That just hooks up. You see these little nodes, right? These things just wire up. So I can just, as I'm in here, I just wire them up, right? And then I have, we can get rid of that. And then I have some tools. So let's do an experiment. And by the way, for those of you following around, that's actually what I'm talking about right here. I think if you want to do this, or you can do here, let's erase that, because I want to do it for, yeah. So I'm going to ask a question. Convert 200 USD to INR. Now, why do I, okay, so converting 200 USD to the Indian rupee. Why does this make a good example for an agentic flow? Well, if you think about it, in order to get the correct answer, the agent has to have up-to-date information on exchange rates, right? So check out what it did. So I happen to know that that's the right answer, but don't take my word for it. What it did here, notice that the agent executed this URL component, right? What is that about? So if I go to the tool, into the edit tool here, you can see I have these names and descriptions. Now, these were generated for me. I did not need to create these. That was part of the tool. But that's enough information so the agent is then able to determine on its own, oh, I have these two tools. They're asking me for this information. I need to go out and get some new information. I'm going to use the URL tool. And so that's what you're seeing here, right? That's exactly what you're seeing here. It's using that URL tool. And now this is where the mix of the knowledge of the model and the tools come into play. Because the model itself had information that it was able to determine, hey, what site might I go to for an exchange rate, right? And it's going to go look. Sometimes it gets it on the first try. Sometimes it doesn't. Sometimes you can see it iterating and going through and being like, hey, I'm not getting the information I need. I'm gonna iterate through. But depending on the model you choose, sometimes it has it. And you can see here that it got information back from that site that is relevant, right? So then in my answer, it says, okay, it's approximately 17,080 INR. Now, let's take that to the next step, though, because I think me saying, oh, it's different from LLM is different from actually being able to see it. So what I want you to do, for those following along, is we're going to go down now to Flow 3, do the same thing, where we're going to pull that one down, we're going to download it, and just drag and drop it into your Langflow. And by the way, that simple agent, while folks are doing that, it's obviously not limited to a URL tool and a calculator tool. I'm going to show you the MCP stuff and how to do that. It's super easy, right? But there are all sorts of tools. So if you look in the components area, you'll see there's all sorts of things you can bring into that. You can also create your own custom tools. Okay, so I'm going to go down to this number 3, simple agent. Now what this is essentially the same exact agent right here, the same setup, GPT-4o Mini, URL calculator tool. The only difference is that down here is the agentic flow, but what we're doing is we're doing a pure LLM up here, also using GPT-4o Mini. So there's no agent here. This is just the model, right? We're going to ask the same question, but we're going to do it in parallel, and then we're going to look at the difference in the output. Because I think, to me, this is super key in understanding the difference between what an agent can do compared to having the same LLM, right, but without the agentic capability. 200 USD to INR. Boop. Now you can see the agent starts to do its thing, great. But in a second you see, bah, there we go. So by the way, just to clarify something. So I have these two different paths, right? I have the LLM path and the agent path. What we've done is we've just made it kind of pretty, right? We just made it so it's easier to read. That's what you're seeing them kind of come together and then put into the output. And that's what's creating this. But check out what happened in the top here. This is the regular LLM, right? Notice that it says using an approximate rate of. Please check a reliable financial news source or currency converter. So what it's doing, it's going off the information that the model has, that it was trained on. It cannot reach out, and it cannot find what the latest exchange rates are. So notice that, okay, yeah, it did the calculation okay, but it's using old data, right? Where the agent is actually able to go out and get the latest data. And matter of fact, it even gave us a nice link that we can go take a look and see. When the agent did that on its own, right? So pretty cool from that standpoint. I hope that kind of illustrates the difference. Now, again, going back to what I said earlier, you may have a case, depending on what you're working on, where using just the model's knowledge is fine. That's fine, right? And matter of fact, when you augment that knowledge with like RAG, and we're going to talk about that here in a moment, then that might be totally fine. You may not need an agent in that case, right? So again, it depends on what you're doing. By the way, any questions or anything like that before I get into the RAG stuff? Anyone? Yeah, go for it.
So the LLM by itself can call some external automation agents like make.com or n8n and then get the information, right? So how does that setup differ from the actual agentic setup?
Yeah, so like I don't know if you were in here earlier, but what it really comes down to is if I pop back here real quick and make sure I'm getting your question right. Yeah, here we go. This. So the agent, the difference is the agent has this runtime, right? And the agent has this orchestration layer and stuff that has short, long-term memory, reasoning abilities, instructions, all that kind of deal. The base LLM does not have that part of the capability, and it doesn't have the tool capability. Right. So that's did it answer your question, by the way, or?
Yeah, I got it. So basically, it has its own runtime wherein it can call the tools, the agent.
Yeah.
Whereas for LLM, we need to set it up explicitly.
Yep. Well, and the LLM does not have access to the tools. So the LLM may have tool function, like tool support, but unless you're using it in this agentic way where it exposes that tool interface, it's not going to be able to use any tools. Yeah. Yeah. All right. Oh, did I see? Yeah, go ahead.
We had a list of models that you were setting up. Are you hosting those, or do we have to do something else to access this tool?
Great question. Yeah. So for model providers that require a key, right, or something like that. Yeah. Actually, I'll just show you. If I go in here, and if I pull a model out, Mistral is a good example. I use them all the time, by the way. By the way, Mistral's CodeStrol is actually quite nice. Yeah? Yeah. CodeStrol, the latest. Mistral just did some updates, and their CodeStrol is stellar. It's great to check out. Yeah. I'll tell you, the landscape is pretty wild west. Like, it's still Wild West. There's still so much happening in the world, and you hear the OpenAI 4.1 release of what they're doing with coding and that kind of deal. I love these little battles. It makes for some interesting work, that's for sure. But anyway, so to your point, your question, yes. So what'll happen is we're just interfacing with their APIs, right? So all of the logic and stuff is really on the provider end for those cases. If you're using something like Ollama for a local model, now that's a little different, right? Okay. All right, cool. Let me pop over. All right, we did that. Let's go. Okay, so let's talk about agentic RAG a little bit. So I want to first do a quick RAG recap, right? So we have the base setup for agentic flows and how that works. Now, I saw a show of hands earlier about folks who have done RAG before, right? A little primer on this one too. So what is RAG? It means retrieval augmented generation. If we break down the acronym a little bit, what we're doing is we're retrieving data that we're going to use to augment the generation of our LLM, right? So again, go back to the example. Let's pretend we're not working with an agent. It doesn't have the ability to talk to the outside world, and the LLM is trained on a certain set of information. Well, then how do you use its knowledge and its reasoning ability for your domain data, your personal domain data, or something like that? That is where RAG comes in. You can take the relevant data and essentially inject it into the context of the LLM during a query, and now it's got this new context, right? So yes, it uses to provide LLMs with domain-specific knowledge. And yes, it doesn't have to be a vector database, by the way. RAG is pretty much any data that you're injecting into the context, right, of the model. Now, I'm gonna watch your faces when I say this, right? Because you see all sorts of the providers, and matter of fact, OpenAI yet again with their 4.1 really just talked about the needle in the haystack problem, right? They did a really great demo. It was actually pretty amazing. You should watch the video, by the way, where they took this huge data set and they shoved it all into the 4.1 model, and they're like, I want you to find this one weird esoteric thing, right? And it does a pretty darn good job of finding that one thing. And I get this question all the time. People are like, I see these posts on X all the time. We're like, RAG is dead. Oh my God, there's a million context windows are totally infinite. It's all dead. No, and here's why. So even if we had a case where models had completely infinite context windows, right? Imagine now, if you just take your whole corpus of documents and you just throw them at the model. Well, you just paid for all those tokens, right? And now you're increasing the processing time. So while the model may be able to do it, you are making it work harder to get to the same result. So RAG is a way that you can essentially pull out the relevant data. Using a lot of cases, if you're using vector databases, where this really benefits is databases have been optimized for decades now to do what? To store and retrieve data, right? They're very, very good at this, and they do it cheaper, right? So I can have this huge corpus of knowledge in my vector store or something like that, use it to pull out just the relevant stuff, and then send that to my LLM. And now it's specific. I mean, imagine if you're doing like a technical support chatbot or something like that, and you want to ensure that when somebody's asking a specific question, that the data it's getting is relevant to the question being asked, as compared to just throwing in every bit of document and everything you have, right? So we'll see if this changes, honestly, with more of the needle in the haystack stuff as the model capabilities get better. But as it stands right now, like RAG is still very, very relevant from that standpoint. Oh, so here's what we're going to do. Now, this is the part that since I don't think anybody here did the pre-work, which is no big deal. I'm not calling anybody out because I don't think any of you had it, really. But if you haven't done it, that's no big deal, right? So what would you, if you have, though, this is where you're going to go to flow 4 and pull that one down. Same kind of process as before. And I'm going to pop that one open. OK. Now, I just want to show you here real quick. So as part of the pre-work, what it would look like is in the pre-work, you create this collection here in Astra called job listings. Now, again, obviously, I'm using AstraDB in this case as my vector store. You don't have to, right? There, again, Langflow has support for all sorts of vector stores. But what it really does here, and where the vector store really comes into play, is in this particular case, what we've done. And this is, by the way, so for those of you who are interested and you want to go play with this, after or something like that, as part of this, there's this huge data set. Thank you, Melissa, by the way, because she's the one who put that together and got all this going. But this is a data set we pulled from like LinkedIn job postings, right? It's this huge data set of all these LinkedIn job postings. And so we created kind of like a pared down version of that for you. And by the way, for those of you who are interested, even though I have set this up so you can do it right in Langflow, here's the Python code too. Right? So if you want to interact just with that Hugging Face data set and you want to be able to inject that into the AstraDB vector store or something like that, you can go either way. Okay. So what's going on here is we have this huge data set, right, of all these job listings. And something that's important, especially when you're dealing with vector stores and everything like that, are the embedding models, right? How many characters, how many tokens can you store, right, per the embedding model? NVIDIA's embed QA is 1024, but if you're talking like OpenAI's 80A02, it's 1536, right? Things like that, So that's part of what you're doing when you're storing the data. But what I'm getting at there is that means that for each of these data, these chunks of data, right, you gotta like chunk them up. Right? And then they're being stored. So you have this natural language being stored and then some metadata. So that's what we've done in here. And if we take a look, I'll actually just show you real quick before I run that. If I go to the data loading part, this guy, here we go. And kind of go like this. There we go. So Langflow also supports, I mentioned there's like, data ingest components, things like that. There's a file component here. There's actually a file in the pre-work, that's this Python and stuff, that's the job listings. So what I've done is I've pulled out, I tried to make it, I pared it down, it's only 7 megs, the original one's like 500 something. I figured that nobody wants to be downloading a 500 meg file on a Wi-Fi at a conference or anything. So it's like focused on data science, software engineering, things like that. But that's this file, right? And then what I'm doing is I'm pulling out the columns from the CSV, right? So they've got their header, I'm pulling out those columns. But then this is the part I'm talking about here, this chunking. Right? So what it's doing, it's going to look at the description of these job postings. Some of them are pretty long. They may surpass the token limit of the embedding model. Right? So you chunk it. That's what this process here is. So when it goes through, it's looking, it's going, oh, well, for as many of these characters, I'm going to create another block, and another block, another block that conforms to my chunk size. Right? And then it's injecting that. This last part here is the part that's injecting that. So it's this flow that's responsible for putting this data here into the database, right? And this is going to form the basis for our RAG. All right, so then, oh, yes, go ahead.
Where do the embeddings take place in this?
That's a great, okay. Yeah, so.
So you split your text into chunks, but it looks like in your flow you're just sticking right into the
Yeah, no, it's a great question, man. That was, you noticed that. So what's going on here is Astra database, right, has this feature called vectorize. So NVIDIA actually is just included. So if you create any vector collection, matter of fact, if I were to do that, and this if you actually go through the pre-work, you'll see this. So you see right here, by default, for any vector-enabled collection, I already have NVIDIA. But you can hook up OpenAI and Mistral and other things directly there at the database level. And then what it does is gives native support to the embedding model. So that is one way to do it. So what's happening to your question is here, because the embedding model is actually just part of my collection, automatically on ingest or at query time, it's going to execute on that embedding model, right? That is a function or a feature of this database. Now, if you didn't have that and you're like, well, wait a minute, dude, I'm not using Astra. How do I do this? Well, right here, not that, this, you can see there's support for all sorts of embedding models. And if I were to come over to this guy, what's happening, by the way, is the AstraDB component is auto-detecting that I do, in fact, have, that I'm using vectorize. So it kind of glosses over those details because you just don't need to know about it. Let's see, where are you? Oh, that's so funny. Let me pull another one over. It auto-detected it, and it's like hidden it from me. Let's see. Where are you? Oh, that's hilarious. You know, Melissa, you don't happen to know off the top of your head, now that I'm at 133, it seems like they changed the component, and it used to...
Depending on the application token and what...
Oh, you're right, that's it, yeah, okay. Yeah, so what it's doing, so the component is being kind of slick, but maybe a little too slick, where, that's right. Let me try a different, let me just grab Chroma or something like that. Yes, this is what I was looking for, yeah. Okay, yeah, our component for AstraDB is being slick, and what it's doing is when I put in the application token for my database, it detects it. And then if it sees that it doesn't have one, it'll expose this. This is what I was looking for, this embedding. So if you have like a vector store and you're like, well, wait a minute, I want to use some embedding model, I can just literally, I'm going to use Cohere or something, pull that out. I would just wire it up, right? So now, similar to your point, right, about what you're seeing in the flow, when I'm doing the split text, the similar way that I'm wiring up the output of the split text into my ingest, I would do the same thing for some other vector store. I've just wired up to the ingest. I'd give it the embedding model I want to use, and then it'll use that embedding model for you.
And then when you're doing the RAG query, you have to use the same embedding model.
On the search, yes.
Is that automatically going to happen in
So,
line change, or do I have to remember to configure that at some other end?
so when you, yeah, no, that's a great question. So when you go to do the RAG search itself, or the RAG query, what would happen is similar. Like here I'm using AstraDB, so it's inherent to it, but let's say I did the same thing I did a second ago, I would do the same exact thing, right? I would grab my vector store, I'd grab the embedding model as long as I match. That's an excellent point, by the way, is when you are storing and retrieving the data in the vector search, you have to use the same embedding model. Once you've retrieved the data, you can do whatever you want with it, right? You can use whatever models, but yeah, you have to use the same one. So yeah, you would just wire it up the same way on the query. Does that answer?
But you have to consciously
Yes.
select the same embedding model. There's
Yeah.
no mode where it automatically says,
You could,
over here you use this model, so we're going to intelligently assume that that's what you want for your...
yeah, because no, there's nothing that does that, because it would actually have to read your data, look at the embedding, like there's no signature that I know of, and I could be wrong on this, that you just read an embedding and go like, yeah, that's definitely this one. Some of them are pretty close. So you're right, yeah, you just have to wire it up, right? You just drag those components up, and yeah, so that is a great point though, like you need to make sure you're using the same one. Now in the Astra case you don't, because it's detecting it for you.
That's
Yeah,
so
yeah.
It detects, it says you did this at the other end, so when you're going to send a query, we're automatically apply this. Okay.
Yes, exactly. All right, so what we're doing here, now this is the same thing. This is the same agentic flow that we were working with before. We have our agent, we have our URL calculator. We don't really need those in this case. But now, this is where we're going to get into a multi-agent scenario, right? We don't have to. I could just wire up my AstraDB tool, right? So any of these vector stores, by the way, they can just become like, I think this is really kind of, you see this tool mode, right? I can make them tools. I can make them tools for an agent and let the agent kind of work out that interaction, right? But in this particular case, what I'm doing here is I'm actually using a sub-agent. So what's going on, right? Well, what we found is that when building out agentic flows, you can get into this like kitchen sink scenario, where if you add on too many tools and too many functions into a single agent, the model gets confused, right? Like it may not do exactly what you're looking for. In the case of the RAG piece, and in particular in this example, I am building a job listings lookup, right? It's that LinkedIn data set, I want this job listings lookup. So I'm actually gonna make one agent a tool of another agent, right? So if I go to any of these agents here, I can make an agent a tool. I can just pop that into tool mode and I can make it a tool, right? So this means that I can have these multi-agent setups. Now what does this do for me? Well, it means that my orchestrator agent can rely on, essentially, it's divvying out tasks, it's collating data, it's kind of putting things together, but it's not responsible for going and getting my agentic data, right? Where this other one is. So if we take a look at the difference in the instructions, this one's pretty basic, right? You're a helpful assistant. You can use tools and perform tasks and things. And I give it a couple of pieces of information, but there's really nothing specific here to getting that job data. But if I look at the sub-agent, there's instructions here. Now check this out. It's specialized. It's specialized. You're a personal job finder specializing in finding job postings on LinkedIn, right? I'm telling it this. I'm giving it instructions that are specific to it. I'm telling it something about the data structure, right? Things like that. And that way, the response from this tool will feed into my orchestrator, and it's going to do a much better job. Imagine, too, if I had a lot of these tools. If I didn't have just one RAG component, right? I had multiple, and I wanted to bring those together. Remember I mentioned the name and description is like super important, right? This one's pretty simple, but I'm telling it specifically. It's a job listings agent. You look these things up, right? So let's go ahead and take a look. I have examples over here on the side if you're using this thing, so. And these examples, they're kind of neat because, again, it exemplifies different, like how agents handle things. So let's take this first one. If I work as a back-end engineer with an annual salary of 120K, how much will I make monthly after deducting 30% for taxes? Well, did this need to use RAG? No, right? It just used the calculator tool. It's just a simple calculator. There was nothing where I'm getting other external data or anything like that, right? So let's go ahead and take this one here. Now, I'm going to do something a little different. I'm going to say, find me the top 5 software engineer jobs available in Chicago. Now check out what it's doing. So the agent was able to determine, hey, I need to use that job listings agent because I'm looking for job listings, right? I'm looking something relevant to that. And if we look back at the logs, by the way, you'll see, and it's going to start spitting out a bunch of stuff because here it goes, right? Yeah, you can see the agent's chunking on it, right? And this is, remember that point I got to earlier about sometimes time and stuff? Get the RAG data just like that, right? But now the agent's got to go do work on it, right? And I've actually given it instructions that said, hey, if you can, find the company website, things like that. But check this out. So I get this result, but if we take a look at our database, in this case, I've got what, like 15,700 rows or something like that. But I don't want all those, right? I just want the stuff that's relevant. So I'm telling it, hey, I want you to give me those top 20 results. Also, if we take a look at what the agent did, so our main agent, right, the orchestrator, it took my natural language query and it pulled out software engineer jobs Chicago. That's actually that's the natural language search that it's going to perform on the vector, the vector database, right? So if I come over to the database and I were to do that and apply that, right, it's actually going to do this same search, and we'll see if the Wi-Fi is going to agree with me this morning. I always love that part. There it goes. And what I really want to point out is, well, for one, if we take a look at the results, software engineer, Chicago, you can see that I'm getting these contextually relevant results from the vector search, but the key thing is this similarity score, these numbers over here, right? The closer to one you are, the more similar it is. The further away, the less similar it is. So I have a lot of results in here. Maybe there may not be as relevant as I get down. So what I'm doing is I'm telling it, hey, I want you to give me the top 20, and I want you to only give me those that have a similarity score threshold of 0.75 or above. Yeah?
Question. So you're talking to the orchestrator agent, right?
Yes.
So when it says what was the input value, is that the input value to the job listings agent? And then does the job listings agent create another
Yep.
The job agent also has a tool.
Yep.
Ask asker.
That's right. That's right.
How do we know it's the same query being passed all the way back? Because in theory, the job agent could say, thank you, orchestrator, for your query.
Yeah.
I could, in theory, rewrite that.
It could. You're right. It could.
Those logs.
Yeah, it is in those logs, by the way. But yeah, that's, yeah. No, you're absolutely right. That's a great point. Agents are not deterministic, right? They are absolutely not deterministic. You may not get the same exact answer every day. You have to put guardrails in sometimes. You have to be very specific with them, right? And that's actually another thing, like doing the multi-agent thing on top of being very specific is kind of a key thing if you want to get consistent results. Right? So that is definitely, that's a really great point. But yes, it could be something else. But no, in that case, that's what that log is showing you. It is showing you exactly what the input was. Yeah. Okay, so great. So in that case, now it looked over that LinkedIn job data. If I look at this, like this is actually providing the LinkedIn links. These are, obviously a little old now, but I'm looking at the max salary of that 250K. That's what it's at, 250K, right? If it can find a website, it is. This one's, Capital One. The agent I asked to go find me the site of whatever it is. The agent's doing that, right? And if we take a look at this last one here, come down here. Now this one's going to be a little different, right? So now again, it's using that job listings agent, but this time I'm saying, hey, are there any jobs for data scientists? What's the highest paying job? How's that different, compared to a role that pays 200K? All these are such, very nicely high paying jobs, right? And again, you can, by the way, while that's running, you can inspect it, right? You can see what it's doing if you really want to. Oh, yeah, there goes the popped. All right, so now again, let me go all the way back up. Okay, so now it went through, again, it's doing the same thing where it's got that RAG. This is the RAG part. It's looking at the top 20 based off of the similarity score. By the way, you can re-rank. For those of you familiar with that, re-ranking is definitely a method to get even more accurate results because just because you contextually matched something does not mean it's always exactly what you need, and the re-ranking really helps in that. I'm not doing that here. But in this case, right, you can see that the agent was able to work out, again, pulling that RAG data. Now, if it didn't have that, I actually instructed it to go to the web, but is it going to get the right data? So this is the RAG case is when I have domain-specific knowledge. I wanted to use that domain-specific knowledge. That would be something maybe you're using for your businesses or whatever. A question I get a lot, by the way, is, well, I don't want to share my business domain knowledge with OpenAI or anybody, like that. And there are options there. That's where Ollama comes into play for local models. That's where things like, Bedrock and Azure, they have, secure pathways that you can use. There are options on that. Okay, so, we've got 4 minutes. So that is the agentic RAG piece. And what I want to do here is I got a couple things. So this is in the Notion page. I mentioned some resources for all of you to take a look at. So this first one here is such a great article on building out agentic flows. The author there just has some really, really great points. That second one is the Berkeley function calling leaderboard that I was talking about. So when you want to find the latest models that have tool support and ratings on like cost and speed and all sorts of stuff, they do that. That agent's white paper by Google is that one that I referenced earlier, right, where I got some of the diagrams and some of the stuff from. And the last one is, we've talked about pure RAG as from a vector search standpoint, but you can combine that with hybrid. Keywords aren't dead, right? They have a place. There's all sorts of, the RAG landscape is evolving just as fast as the model landscape. And what we have found, especially for, for the folks that are building with us and that kind of deal, is that more and more and more, obviously, accuracy really matters, right? Especially when you're working, if you're gonna build an agentic chatbot or something like that, that is a travel bot or one that is giving very specific technical information or something, they got to be accurate. Because if you have a user who you send down on a wild goose chase and they went and spent hours thinking that they had the right answer and you come to find out wrong, they're not going to trust your agent, right? So the accuracy part really matters. Okay, by the way, those are at the bottom of the Notion page. So if you already scanned that first page, you have all of these. So if you miss a QR code, no worries. I think you already have Langflow by now. If you want it, there's the site. But I have something fun for you in our last 2 minutes, which is this one. So how many of you have a GitHub account? Probably most of us. If you don't, no worries. Scan that code. That's going to take you to a site called codebeasts.ai. That is actually something that I built. I'm sorry. Let me put that back. Here we go. So I don't know how many of you have seen this latest trend of doing the action figure thing. But when you go to codebeasts.ai, action figure is one option. There are a bunch of others. What it's going to do, put in your GitHub handle, When you say generate, it's actually using an agentic flow. It's going to look at your GitHub repository. It's going to look at your profile. It's going to scan your repos. It's going to look at the languages that you use. It's going to use that to form and build a prompt for a vision model to go and build this. There is a mode in it. You'll see choose image, right? It's an optional thing. If you take a selfie or just give it an image, it'll make one of you, right? So if you went, and you can see, like in my case, like I have Python, like the snake in there. It'll like take in various things. So for those of you who are so inclined, and as a matter of fact, let's see, there it is, yeah. Yeah, here's the code base thing. So you can see that there are other, we actually had, yeah, here's Allison from, she may not, from the event. She did one this morning, right? That's her. So this is kind of a fun case. This is just a fun case, right? Of something that is actually using, I think I saw it a second ago, by the way. Where'd it go? There it is, yeah, I have. Yeah, this is the code base flow. All of a sudden I can, there we go. Oh, I see what's going on. I'm too zoomed in. There we go. Yeah, this is actually the code base flow. This actually takes into account, obviously there's a lot going on here, but this takes into account like looking up the database, agents with tools that can talk to GitHub and everything. It's doing all sorts of memory and things. You've got like the session ID you can use to kind of like encapsulate like just specific user information. All sorts of things are in here. But this is an example of using an agentic flow where now I can expose this as an API endpoint, and my front end just ties into this. So my front end doesn't need that logic. My front end is just essentially a consumer, right? Anyway, with that, thank you. I know we're at time. Oh, what do we? Oh, go for it. Do you want to put it up?
Yeah.
Go for it. I think Melissa is going
Sorry to steal your thunder.
Oh my God.
If it comes up. Thank you to everybody who stayed till the end for David's
Yes,
workshop.
thank you, thank you.